Let's break down three important concepts in operating systems: multitasking, multiprogramming, and time sharing. First up is multitasking. Multitasking refers to the ability of an operating system to execute multiple tasks or processes seemingly at the same time. This doesn't mean that the CPU is working on all tasks simultaneously, especially since most systems have a limited number of CPU cores. Instead, the operating system rapidly switches between tasks, giving the illusion that all tasks are running at once. For example, imagine you're writing a report in a text editor while listening to music on a media player, and your antivirus software is scanning your system in the background. Each of these activities feels like it's happening simultaneously, but in reality, the CPU is switching between them very quickly, which is what creates the multitasking experience. Next, we have multiprogramming. Multiprogramming is an older concept where multiple programs are loaded into memory and can run, but only one program is executed by the CPU at any given moment. The operating system decides which program runs based on which program needs CPU time and which one is waiting for input-output (I/O) operations, like reading from a disk or waiting for keyboard input. The key here is efficiency. While one program is waiting for input-output, the CPU can work on another task instead of sitting idle. Imagine you're cooking several dishes at once. You start boiling water for pasta, and while waiting for it to boil, you chop vegetables. As soon as the water boils, you go back to cooking the pasta. You aren't actually cooking both dishes at once, but you're using the waiting time productively. That's essentially how multiprogramming works. One process runs, and when it's waiting for something like input from the user, another process can run in the meantime. Finally, let's talk about time sharing. Time sharing is an extension of multiprogramming, but specifically designed to allow multiple users to interact with the system at the same time. The CPU time is divided into small chunks called time slices and distributed across users or programs. The operating system rapidly switches between users, giving the illusion that everyone is working at the same time. Time sharing makes sure each user gets a fair share of the CPU's processing power. Picture a university computer lab where multiple students are logged into the same server, working on their assignments. The server gives each student's program a small time slice, then moves on to the next student, and so on. The students don't notice this rapid switching, so they feel like they have full control over the server all at once. Now, let's sum up the key differences. Multitasking focuses on running multiple tasks within a single user environment, like writing a document while also browsing the internet and listening to music. Multiprogramming aims to improve efficiency by switching between programs that are waiting for input-output, making sure the CPU is always doing something useful. Meanwhile, time sharing allows multiple users to use the system simultaneously by sharing CPU time, making sure everyone gets a fair share of resources. Think of multitasking like one person flipping between different activities, checking their phone, writing notes, and listening to music. They aren't doing all activities at once, but they're switching between them very fast. Multiprogramming is like cooking several dishes at once. You manage tasks by switching between them when one is waiting. Time sharing, on the other hand, is like a group of people sharing one computer at the same time. Each person gets a little time with the computer before it switches to someone else, but it happens so quickly that it feels like everyone is using the computer continuously. In conclusion, multitasking gives a single user the illusion of running multiple programs at once. Multiprogramming increases system efficiency by managing several programs and switching between them when one is waiting for input-output, and time sharing extends multiprogramming to support multiple users, giving each a fair share of CPU time. These concepts have evolved to make computing more efficient, responsive, and user-friendly, each solving a different challenge in system performance and user experience.